Okay, for 7b then, what if you increase or decrease the volume or increase or decrease the pressure? Well, one thing to keep in mind, if you change the volume, you will change the pressure. So if you change the volume, it will only affect the equilibrium if you have different amounts or different moles of gas on each side. So two things have to be true. First of all, you have to have a gas on the reactant or the product side, and you have to have different amounts on each side. So even if you only have gas on one side and no gas on the other side, it will have an effect because there's more gas on one side since there's no gas on the other side. But if you have 3 moles of gas on each side, even though they're gases, they're going to be equally crowded, so it won't have any effect. But if you have gases and you don't have equal amounts on each side, then changing the volume will affect the equilibrium. The more crowded side will be affected more by increasing or decreasing the volume because it will become more crowded or less crowded, just like the school bus. If you have 25 kids, each sitting in their own seat, adding a few kids, removing a few kids, not that big a deal. But if you already have 2 kids to a seat on the bus and you add more or you take away more, that's a much more noticeable effect. So, what happens when you increase volume? It makes particles less crowded, so fewer collisions occur on both sides, but it means the more crowded side will see a bigger decrease in collisions and it will pull the equilibrium to that side. If you decrease the volume, you make the particles more crowded, so more collisions occur, and the more crowded side will have a bigger increase in collisions and push the equilibrium to the other side. So there's not a way to just say reactant or product. You have to look at each equation and see which side is the more crowded side as far as gases go. Same thing is true with pressure. Changing pressure will only affect the equilibrium if you have different amounts of gas on each side. And again, the more crowded side will be more affected by changing the pressure because it will become more or less crowded. Decreasing pressure, that would be just like increasing volume. They have an inverse relationship. So one goes up, the other goes down. Decreasing pressure also makes particles less crowded, so fewer collisions will occur, and it means the more crowded side will pull the equilibrium that way. Okay, decreasing pressure lets the less crowded side see a bigger decrease in collisions, and the equilibrium moves to the more crowded side. But increasing pressure, I'm sorry, I got a typo here. This should be increasing pressure is going to make the particles more crowded. So the more crowded side is going to see a greater increase in collisions and it will push the equilibrium to the less crowded side.